Hello students, I hope you all are fine. Today we will talk about a topic which is known as helicity and chirality. Helicity is basically a concept of physics, and it can be defined as the projection of spin of a particle onto the direction of that particle's momentum. Normally, this concept is used in physics as well as chemistry, but since we are considering the course of chemistry, so in chemistry we say that helicity basically describes the orientation or the sense of twist of a three-dimensional molecule. So you just consider this spinning object, you can see it's spinning in a certain direction. It means it has some helicity. Similarly, if you can see this molecule, this is known as the helicin. This is basically a polyaromatic molecule. This molecule also has some sense of a twist. It's also helical. Why we are saying that as a twist? Because we know from the stereochemical aspect that whenever you have a wedge-like structure in a molecule, it means that wedge has orientation above the plane, and the molecule or the part of groups that are shown by a dotted line means those groups are below the plane. So according to the stereochemistry, when we see the sense of twist or the direction of orientation of spin, we go from above to below side. So here we are moving from above to below side, and the direction is the anti-clockwise. So anti-clockwise is shown by a minus sign. So here M stands for minus, right? And whenever we have a minus sign, we say that it's left-handed twist, right? So if any molecule that is chiral, that is spiral or has some sense of twist, we say the molecule is helical. And whenever there is helicity, there is a quality of a molecule called chirality. So chirality is basically defined as the property of asymmetric molecule where the molecule and its mirror images are not superimposable, just like our hands. Right? So if we see one of our hand in the mirror, the other hand of ours is exactly the same, which is being shown in the mirror. So the two hands, our left hand and the right hand, are mirror images of each other, but when we place one hand over another, then in that case the two hands, they are not superimposable. They do not match with each other. So just like these, the chiral molecules have the property of handedness. They exist in two forms. One is like a object and other is like the mirror images, and these two distinct forms are called the enantiomers. One enantiomer cannot be converted into other enantiomer by simple rotation. So the chirality and helicity, how these are related. The chirality often arises when any organic molecule has a carbon that has 4 different groups attached to it, right, or 4 different substrates attached to it, creating a tetrahedral arrangement. Just like these two groups, these are mirror images, and each carbon has 4 different groups attached to it. So these are enantiomers. So an enantiomer is called the R enantiomer, other is called the S enantiomer. So why they are called R or S, we will discuss in some other day. But here we can say that these two molecules, they are mirror images of each other. So they are enantiomers, and these mirror images are not superimposable. Some molecules, although they do not have a chiral center, but they are chiral. So one thing we should mention here, that whenever an object is chiral, means it has the property of handedness. And thus, what do you mean by handedness? It means those two objects, they are exactly mirror images of each other, but when we place them on one another, they are not superimposable, they do not match with each other. So these are chiral objects, and whenever any chiral object is subjected to plane polarized light, the plane polarized light is either rotated in clockwise direction or anti-clockwise direction. Right, so the chirality is actually related to this optical rotation, means the interaction of the molecule with the plane polarized light. So some molecules, although they do not have a chiral center means that carbon has 4 different groups attached to it. So there are many molecules in organic chemistry that do not have a chiral center, but they are chiral because they are helical. Just check this macromolecules, they're called allegens. So one molecule, it has anticlockwise twist and the other has a clockwise twist. Similarly, we know that our DNA has a helical structure. So DNA can twist in clockwise direction or anticlockwise direction. So whenever it has rotation in clockwise direction, we say it's plus or P, or if the direction is anticlockwise, then we say that helix has a minus direction or anticlockwise direction, right? So helical molecules do not have a chiral center, but they are chiral because they are helical. So you just understand that when we say that helicity that gives rise to chirality, it means the molecule does not have a chiral center, but they will be chiral, means they will rotate the plane polarized light either in clockwise or anticlockwise direction because of the nature of twist or spin in those molecules. So here are some examples of organic molecules having helicity of chirality. So we have these polyaromatic hydrocarbons. Here you can see that if you move from above to below, the direction of coil is anticlockwise. So this is a plus or P orientation molecule, and the other, if you see from above to below, we see this molecule has direction of anticlockwise. It means it has minus orientation. Similarly, the binephthals and biphenyls, they have helicity of chirality. This is molecule of allene. Allene also has helicity of chirality. These are spiro compounds, again helicity of chirality. And here I've included an image of sprouting from a seed, and this is example of nature showing helicity of chirality. So I have a feeling that from today's lecture you will have a clear concept what is helicity and how it is related to chirality. So if you have any question, please drop in the comment section and I shall respond to you certainly. Thank you so much for your attention.